Now we will learn about distance time graph. Okay, distance time. So two quantities I am telling here. Two quantities. Again I am telling what is a quantity? The things which we can measure. Okay, so distance we can measure, time we can measure. So what is the relationship between the distance and the time based on different situations that you are going to plot here. Okay, so first I am taking one example. Suppose it's a long time the movies, that is halls, are not opened, or shopping malls are not opened. But nowadays a lot of shopping malls are opened. So suppose you went to a shopping mall with a car, and there you kept your car at the parking place. Okay, and you are waiting for your friend at the gate of the mall. Okay, at the gate of the mall you are waiting for your friend and your car is at the parking place. Okay, now you are standing, waiting, watching the time, waiting. It's a long time. Okay, now in between this time, this situation, I am going to plot it on the graph. Okay, let's do it. Now the distance between you and your car. Okay, now the distance between you and your car is suppose 30 meter. Okay, the distance between you and your car is suppose 30 meter at that time, because your car is at the parking place and you are at the gate. Now you are at the gate, that where is the gate? That is the origin. That one you are considering about the origin. Okay, so each and every time whenever you are plotting, you need to consider the origin, which is the reference point actually. That with respect to what you are considering the distance. Okay, so what have I told? That where you are standing at the origin and your car is 30 meter away from you. Okay, 30 meter away from you. Now I am going to plot that one. So this time I am just taking the positive, that is the first coordinate, first quadrant. So what is that? Plus x is along this side, plus y is along this side. This is the origin. Okay, origin's coordinate is 0, 0. That we all have learned. Now the situation when you were waiting. Okay, that time is running continuously. Time is running continuously. You are waiting for a long time for your friend. And the distance between you and the car, you are observing. The distance between you and the car. So you are observing that what is the condition of the car. Car is at which condition. That part you are going to plot. So the distance you are considering. So when it was 0, that when the time started, means from which time you are going to start counting time. At that time distance was 40 or 30, I have told, I have forgotten. Okay, let us write it down as 30. Now time was in minute and distance was in meter, I have told. Okay, so 0, 30 is the first quantity. Now 1 minute gone, car is not moving, that's why, and you are also not moving, you are also waiting at the gate only. So the distance between you and the car is fixed. 2 minutes is over, the distance is fixed. 3 minutes is over, the distance is fixed. 4 minutes is over, the distance is fixed. 5 minutes is over, the distance is fixed. Okay, so only till this much I am going to plot here. Okay, so can you remember in the last video what have I told? Along x-axis what should I plot? the independent quantity. Now you check what is the independent quantity. Time is the independent quantity because time is not waiting for anybody else. Time is not dependent on anything else. Isn't it? So along x-axis I am plotting time t. We need to write down the unit in minute. Time t in minute. Okay. And along y-axis I am plotting distance d in meter. Distance d in meter. Okay. Time t in minute. Okay. Now I am going to write down the mark, that 1, 2, 3, 4, 5. Till 5 I have plotted. So let us mark it 1, 2, 3, 4, 5 like that. And here I am taking as 10, 20, 30, 40 like this. So write down 1, 2, 3, 4, 5. That is 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes like that. Okay. And this one I have taken as 10, 20, 30, 40. That is 10 meter, 20 meter, 30 meter, 40 meter like this I have plotted. Now this is also another important thing, that the scale, this is called the scale. The scale should be chosen in such a way so that your entire graph gets filled. Okay. I will not here, since the value is 30, I will not start from 1, 2, 3, 4. Okay. Then 30 will just cross the board. That's why I am choosing the scale like this, 10, 20, 30, 40 like this. Okay. So choice of scale is also another important thing. So slowly how you will practice more, you will learn it, you can cope it very nicely. Okay, so let us do the first thing. So time 0 and the distance was 30 meter. So time 0, distance was 30 meter. Point is here. Okay, time 1, that is 1 minute, 30 meter. So 130 is the next coordinate. So 1 and then 30, next coordinate. Then 2:30, that is 2 minute and 30 meter. So this one is the point. So 3:30, so 3 minute, 30 meter is the next point. 4:30, so 4 minute, 30 meter is the next point. 5:30, so 5 minute, 30 meter is the next coordinate. Okay, so I have got so much points. So let us join it. Oh, I have joined it. And I have just extended it. Joined it and extended it. Okay. Now, what is this? Now, the line which I have plotted here, this is only the graphical representation of that situation where you are explaining your data about or the relationship between the time and the distance for that situation. Okay, so what if this data is showing you and the line is showing you that this is a straight line which is parallel to x-axis. Now along x-axis I have plotted the time. So line parallel to time axis in the dt graph, that is in the distance time graph, line parallel to time axis represents body is at rest. Body is at rest. Okay. So once again I am repeating, line, a straight line parallel to time axis. Straight line parallel to time axis in the distance time graph. In the distance time graph represents that the body is at rest. Okay. Now here in this case Car was not moving. Car was at rest. Okay?